All right, let's just dive right into it. Welcome to today's Explainer, where we're going to completely dismantle and then rebuild your entire approach to breaking into the AI industry. I'm so excited you're here because we have a ton of ground to cover. If you're trying to learn machine learning right now, you've probably noticed that the landscape is just overwhelming. But here is the hook, and it's absolutely crucial you hear this. The machine learning career advice from 2019, it's officially dead. The path that got people hired just a few years ago simply won't work in 2026. So today, we're going over the exact, pragmatic, step-by-step roadmap to learn ML the right way, right now, without wasting a single second of your precious time.
I wasted 6 months learning ML the wrong way, getting lost in math. Man, does that feel a little too real or what? I want to take a quick second and just empathize with you here, because this is exactly what happens to so many brilliant, highly focused learners. You start a course, someone tells you that you absolutely have to master calculus, and suddenly you're just grinding through dense math textbooks for months. And the worst part? You aren't getting any closer to actually landing a job. It's incredibly frustrating. It feels like you're studying for a PhD instead of, preparing to build actual products.
Now, what's really interesting about this slide is the sheer contrast between the old world and the new reality. That 2019 path, it was highly academic, it was theory-heavy, it was incredibly slow, and it demanded you sit there deriving complex math formulas by hand. But the 2026 path, it's pragmatic. It is 100% project-based, and it's built entirely for speed and real-world application. The industry has totally shifted. They don't want researchers anymore, they demand builders who can actually deploy models into production.
So, how exactly do we navigate this chaotic topic? Well, we've got a very clear game plan today. We're going to cover Number 1, why the old advice is dead. Number 2, building a pragmatic foundation. Number 3, escaping tutorial hell. Number 4, building professional portfolios. Number 5, navigating the 2026 AI reality. And finally, number 6, actually landing the job.
Section 1. The old advice is dead.
Look, the biggest myth floating around right now is that you need some advanced math degree to be useful in AI. Let me tell you, spending your weekends proving the chain rule by hand, it doesn't actually give you the intuition you need for production machine learning. Instead, we need to apply the Pareto principle. You know, the famous 80-20 rule. In machine learning, 80% of your actual job offers are going to come from just 20% of your effort. So we're going to use this rule as our ultimate secret weapon to strip away all that academic fluff and focus exclusively on what actually gets you hired.
Section 2. The Pragmatic Foundation.
Okay, so here is the 80-20 rule in action when it comes to mathematics. Like I said, you really don't need a math PhD. You just need a working intuition in 3 core areas. First up, linear algebra. You just need to understand matrix operations so you know how data transformations actually work under the hood. Second, calculus. Focus purely on derivatives so you grasp the concept of backpropagation. And third, probability and statistics. Here you just want to focus on distributions and Bayes' theorem so you can evaluate a model's uncertainty. That is literally it. Your goal is to build a visual intuition, not to memorize complex proofs. There are incredible, totally free resources out there, like Khan Academy, 3 Blue 1 Brown's animated math series, and StatQuest, and they are all you really need here. You should cap this phase at just 2 to 4 weeks. Seriously, do not spend months on this.
Right, so once that math foundation is set, you're going to immediately move into programming. And let's be real, Python is the absolute, undisputed default language of machine learning. You'll want to start with core Python, things like variables, loops, and functions. Then step 2 is mastering pandas and NumPy. Real-world data is super messy, and pandas is basically a data manipulation powerhouse that lets you clean and transform tabular data efficiently. Finally, step 3 is grasping the basics of scikit-learn, which is pretty much the gold standard library for traditional machine learning algorithms.
Section 3. Escaping tutorial hell. So this is probably the biggest trap for aspiring engineers. The illusion of progress you get through passive watching. You know the exact feeling. You watch a 10-hour video, you're nodding along, feeling great, and then you open a code editor and your mind just goes completely blank. We're going to fix that right now with some rapid-fire habits. Do build real projects. Do implement code from scratch. Don't waste your time memorizing algorithms, and absolutely do not copy-paste blindly. To bridge that gap, interactive platforms like Scrimba are fantastic because they literally allow you to pause the video, break the code, and then fix it yourself right inside the player. Remember, active learning always beats passive watching.
And if you want the ultimate hack to truly escape tutorial hell, it's what the experts call the genius move, implementing from scratch.
Instead of just lazily calling a function in scikit-learn, try coding a basic algorithm like logistic regression purely using NumPy arrays. When you actually force yourself to write out the math and see how the data flows step by step, that abstract theoretical math suddenly turns into a deep, fluent understanding. Plus, as an added bonus, it doubles as the absolute perfect preparation for coding interviews.
Section 4. Building professional portfolios. Now we've got to shit to the harsh reality of the job search. Let me just be totally blunt with you. Hiring managers are not impressed by your course certificates. Have you ever found yourself sitting there asking, why aren't I getting any interviews? You feel like you did everything right, but you just can't get past that initial resume screen. It is universally frustrating. But the answer to this mystery? It almost entirely lies in what is, or let's be honest, what isn't on your GitHub profile.
And this brilliantly illustrates the difference. A beginner project uses a super clean, spoon-fed Kaggle dataset, it lives entirely in a Jupyter notebook, and the performance metrics are just handed to you on a silver platter. A hiring manager learns absolutely nothing about your actual engineering skills from this. But a professional project, that's a whole different ballgame. It uses real, messy user data. It's containerized with Docker, deployed on something like AWS, and it's got a full CI/CD pipeline. Taking a model from an idea all the way to production proves you can actually operate in a real-world engineering environment.
Section 5. The 2026 AI Reality.
Okay, so we've experienced a massive shift in the industry recently. Classical machine learning definitely still matters, but it now has to share the stage with a totally new discipline, AI engineering. To be a competitive engineer in 2026, you absolutely must understand two modern necessities, RAG and evals. RAG, which stands for Retrieval Augmented Generation, is all about giving a language model specific context, so it doesn't just hallucinate nonsense. And evals? That's systematically measuring if the AI's output is actually, good and safe to use. Building these rigorous evaluation pipelines for Gen AI systems is a huge chunk of the job market right now.
Now, as you navigate this wild new AI landscape, you are inevitably going to use AI coding assistants. In fact, it's pretty much mandatory. Professional engineers use them every single day. But you really have to beware of the fluency illusion. Do not outsource your cognitive thinking to ChatGPT. When an AI hands you a flawless block of code and you just copy-paste it while nodding along, you might feel like you understand it, but you really haven't done the mental heavy lifting to make that knowledge stick. So use AI to explain complex concepts or quiz yourself for sure, but never let it write code that you don't deeply understand. It will literally destroy your long-term progress.
Section 6. Landing the job.
All right, so you've got the skills, you've built the portfolio. Now, how do you actually get your foot in the door? The secret is 10x. Look, studying in isolation is by far the slowest way to learn. But when you step out of your little bubble, when you network and actually share your work in public, it accelerates your learning and your career opportunities tenfold compared to just grinding away alone in your room.
And no, you don't need to be a tech nepo baby to get referrals or get hired. You can proactively build your network starting today. Go attend industry conferences, be highly active and genuinely helpful in online communities like Discord and Reddit, collaborate on open source projects on GitHub, and reach out to engineers you admire with thoughtful, well-researched questions. Trust me on this, real projects paired with real human connections will beat a stack of certificates every single time.
So, I'm going to leave you with this final, somewhat provocative thought. Are you ready to close the tutorials and actually start building? You know the 80-20 rule now. You know exactly what math you need and what you can safely ignore. You know that a single deployed project is worth 100 dusty Jupyter notebooks. The path forward isn't about just grinding harder, it's about learning smarter. So, take that very first step out of tutorial hell today. Open up a blank file, find some messy data, and just start building. You've got this.